Hi students, today we are going to study the superposition of waves. Up till now, we've studied things like the physical properties of waves, like the velocity of the wave, the energy contained in the wave. We've described the equation of a wave. Today we're going to do something interesting. We're going to see what happens when two waves interact with each other. Like this. What will happen now? The interaction between two waves is governed by the principle of superposition. The principle of superposition states that when two waves are moving through the same medium particle, the displacement of the medium particle will be the sum of the displacement caused by each wave. You see, what this statement simply means is that the displacement in a medium particle caused by the combination of two waves is simply the sum of the displacement caused by either waves. So have a look here. Let's say there's this wave which is causing a displacement y equal to a sine omega t minus phi in a medium particle. Like this. Now what will happen if there's an other wave exactly similar to the first wave? Like this. Y equal to a sine omega t minus phi. If these two waves are traveling in the medium, then according to the principle of superposition, the final resultant wave will be y equal to 2a sine omega t minus phi. That is the sum of the two waves. And the medium particle will be displaced like this by double the amplitude by the resultant wave. So we can conclude that if there is a wave which displaces the medium particles in accordance with y1 equal to a1 sine omega 1 t minus kx, like this, and if there is another wave which displaces the medium particle such that y2 equal to a2 sine omega 2 t minus kx, then the resultant wave is simply y1 plus y2. Like this. In this case, we've taken exactly the same k, that is 2 pi by lambda in case of both the waves is just the same. However, this is not necessary. We've done it simply to make it easier to depict the graphs of the waves. So whenever you have to add the displacements of any two waves, all you have to do is add their equations, y equal to y1 plus y2. In this case, of course, we are assuming that the displacement caused by each wave is in the same direction. For example, this wave is a transverse wave traveling to the right. So the displacement of particles is in the direction parallel to the y-axis, that is like this. In this case too, the displacement is parallel to the y-axis like this. That is the reason we've simply added the two equations, y1 plus y2. But you have to be careful if one of the waves is traveling in a completely different axis or at an angle to the x-axis. For example, if this wave was traveling along the z-axis, that is the axis that is protruding towards you from the computer screen, and this wave was traveling in the x-axis as it is traveling right now, then you wouldn't be able to write y equal to y1 plus y2. In that case, you would write y vector equal to y1 vector plus y2 vector. In this case, we are adding the displacement straight away because they are all in the same direction. After all, if our wave is traveling along the x-axis, in case of a transverse wave, the displacements will always be along the y-axis. Got it? So fine. We've understood that if two waves are traveling in a medium, we can simply add their displacements to get the displacement of the resultant wave.